We're now going to establish some identities. For example, we want to establish the identity that the sine of pi over 2 plus theta is equal to the cosine of theta. To establish this identity, we're going to simplify the expression on the right using the sum formula for sine. And what we get there is that the sine of pi over 2 plus theta is the sine of pi over 2 times the cosine of theta plus the sine of theta times the cosine of pi over 2. And we're arguing that this is equal to the cosine of theta. Well, the sine of pi over 2 is 1, so we have 1 times the cosine of theta plus the sine of theta times the cosine of pi over 2 is 0. And again, we're arguing that this equals the cosine of theta. Well, 1 times the cosine of theta is the cosine of theta. Sine of theta times 0 is 0. So we have cosine of theta equals cosine of theta, and we've established the identity. Let's try and establish one additional identity. The next identity that we're going to establish is sine of alpha plus beta divided by the sine of alpha times the cosine of beta equals 1 plus the cotangent of alpha times the tangent of beta. I would argue that the left-hand side is the more complicated side. The numerator is going to simplify using the sine formula for the sum of two angles. The sine of alpha plus beta is the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. And this is all divided by the sine of alpha times the cosine of beta. By the way, to remember these formulas, it's probably helpful to think of it in the following way. Say the sine of the first plus the second, where the first refers to the first angle, the second refers to the second angle. So the sine of the first plus the second is the sine of the first times the cosine of the second plus the cosine of the first times the sine of the second. And we're again arguing that this equals 1 plus the cotangent of alpha times the tangent of beta. Now what we're going to do is take sine of alpha cosine of beta and divide it into each term in the numerator. The result is sine of alpha times the cosine of beta over sine of alpha times the cosine of beta plus cosine of alpha times the sine of beta over sine of alpha times the cosine of beta. And this is supposed to equal 1 plus cotangent of alpha tangent of beta. Now, this expression, sine of alpha over sine of alpha, divides out. Cosine of beta over cosine of beta divides out, and we're left with just 1 plus cosine of alpha over sine of alpha is cotangent of alpha. Sine of beta over cosine of beta is the tangent of beta, and that's exactly what we have on the right-hand side of the equation, and therefore we've established the identity.